A lot of testing is done at scale after deployment, or before deployment but after development in code. We're going to look at some approaches to usability testing, particularly quantitative but also qualitative, in the design cycle, which is a somewhat unique take. If you imagine a screen, it could be a web app, single page app, whatever, and we're going to make a high-res prototype that's HTML and clickable, but it's only a client-side instance. And then we're going to run a bunch of JavaScript and conditional logic in this prototype that can make REST calls and API calls to whatever we want. Rather than just running a code from some tool provider and relying on them 100%, we're going to push events into anybody we want, not just tool vendors, but also into our own repository, so we can analyze it anytime we want with the best analytical tools, Tableau, R, SPSS, Power BI, etc. I'm going to be using Piwik Pro, which is an open source repository, but this could be done with Snowflake, a variety of Amazon repositories, Databricks, Segment, etc. So here's a summary of what we're going to do. We're going to run a prototype and push API calls anytime any event happens, any buttons pushed, if there's a drag and drop, if there's opening and closing things. These will generate JavaScript calls that will go to MouseFlow and that will go to Piwik, the repo, and then we can pull up this raw data in Excel and massage it and look at it in R and even GPT. So here's the prototype, and imagine that you're a test subject. You've been invited to this link and you see some simple instructions here. There's a navigation system on the left that's got some reports in it, and then some of the reports are in folders that you can open up. So financials a folder, utilization's a folder, and we want to make a new folder. So create a new folder, name it, add a report to it, and exit. So the user would go into the settings and see that they can add a folder here. They can then name the folder. We'll call it my new folder. They could write a description and save it. And then they get a little message here, drag report. And so they can take, for instance, the savings and risk trend report, drag it into the new folder, and then immediately over here, this popped in, which is your new folder, and whatever you want to, you can drag any arbitrary number of reports into it. And so now we need to exit, and we need to also look at the info. So this would be the description that was part of when we saved the folder name. Because of the MouseFlow API calls that are being made as you go through this, it popped up a survey, and I can say, how would you rate the ease of use of this feature on 1 to 7, very difficult, 1 very easy, and I'm going to say, oh, it's about a 2. And then I can close that, and I'm pretty much done. So now let's go look at the MouseFlow part of it first. This is a screen full of captures that we've taken with MouseFlow using the JavaScript API and the MouseFlow capture code. And each one of these is a capture session. So let's look at the most recent one, which we just ran. You're going to see that this captured the whole session. So even like when I was talking about giving the instructions. So let's skip past that and see if we can find where I actually start running it. Okay, so here I'm clicking through. This is a double time. Here's where I type it in. It obfuscates the input, although that's a setting that can be changed. And here I'm doing the drag, and here I'm looking at the new folder and closing it and doing my psychometrics, and there we go, and we're done with this session. MouseFlow is great. You can do a lot of very detailed analysis and heat maps, and it's a very broad, deep system. So now let's look at where that data actually went besides mouse flow. It went to PWIC, which is a big, mature, partly open source and partly paid service that captures and does analytics on usability data. So if we go into the reporting section and let's actually look at the debugger, because this is the very latest stuff, and you can see this is a record right here. This is today's date and time, and you can see in chronological order the actual JavaScript calls. So every button click, every mouse drag, everything done in the UI is sent as a custom event from Acture to this repository. So you can see button 1, button 2, an icon click, and I think there's a drag here, and basically just 7 sort of events in a completed task. So any of the data from this repository can be exported, and when it's exported in CSV form, it looks like this. There's a lot of user agent stuff in the left-hand side: a session ID, event ID, IP, the normal stuff you'd expect from web reporting, IP address, browser, operating system, screen resolution. But then when you get further into the table, there's the custom stuff. And one of the key things is this cookie ID, which is essentially a session ID. You can see there's 7 events that end in C9CA, and those correspond to the custom JavaScript events that Acture pushed into the repo. So we've got the custom event name that tells what happened. And we also have a timestamp right here, and this timestamp was actually generated by the client. It's not dependent on any of the testing infrastructure, and it's just pushed with JavaScript here. And then from this raw log, we can do formulas and roll this stuff up. So that C9CA set of events in one session got rolled into a unique record with the minimum. So it grabs the minimum timestamp and the maximum timestamp in that session and calculates the difference. So this gives us a time on task metric, and then this counts the clicks in that session, and if there's not 7, it flags it as not complete. So this gives us complete and not complete, and then here's the Likert results from the survey, and there's also can be a little A/B testing, which is also done on the client side and just pushed here for analysis. We looked at how the clicks get captured, but we can also look at how the A/B testing works on the client side strictly. So when the user comes in and adds a folder and starts to name it, this click right here creates a random number between 0 and 1 and does the A/B calculation on that. So we're just using the color of this alert as the A/B test, and there have been even more subtle things that made big changes in usability. So let's reload this. Let's just see if the randomization is working. Let's reload it, go back in, save it, and it's yellow. Reload it, go back in, save it, and it's red. And essentially, it's like flipping a coin for the A/B test. And to see how that works behind the scenes, here inside Acture, there's the Save button you're clicking, and you can see over on the right, there's some JavaScript that does the UI work, hides the dialog, and shows the alert. But right here, you can see that it's doing creating a random variable. And then the conditional logic down here essentially says that if the value of that random number is greater than 0.5, show the red alert. If not above, you do the yellow. So very simple, straightforward randomization taking place strictly on the client side. So we got our data, we got it into Excel, we crunched it down into one record per user session, and now we get to use some of the wonderful small-scale statistical methods from Searle and Lewis. And they have this in-depth textbook on all the methodologies, but they also have a companion for Excel and R, and as part of this companion, they provide R functions that basically support all the methodologies in their system. Let's look at how it works in R. I've moved some of the task times, a set of 28 task times for an A test and a B test, and the Likert ratings and the completion, and move them all in as variables in R. First set of task times had a mean of 57 and a standard deviation of 15. The second one had a 52 mean, which is less, and a very close to the same variance. So the question is this difference between 52 and 57 significant? So there's a nice function to look at that. It's an independent t-test. We'll pass it both sets of times and run that. And what we get is that the difference is around 4.58, and the confidence interval around that goes down to -3 and up to 13. And so that's straddling 0. That might not be a significant difference between those two. But let's look at all these things in visualizations, and that will help. Like starting with maybe a box plot, which looks like that, and these are time on task numbers, so they tend to be positively skewed, which you can see here by the longer tail. If we compare the mean and median, that also supports the fact that the mean is larger than the median, so that supports the positive skew. But we can actually look at the skewness number, which is 60. If it's over 0.5 to 1.0, it's a moderate positive skew, which is what we see here. We can also run a histogram, which looks like that. And you can see the 60 is pretty much sitting in the middle of the normal distribution, and then here's the density plot for the time on task, and with that right-hand skew. And maybe just one more. Here's a dot plot showing the confidence intervals. Load that library, and now run this, and the dot plot looks like this. And then finally we can look at plot for the A/B test, which we can do a simple one, I think, that looks like this. So we see that difference between the means less than 5, and then we see the straddling confidence intervals. And I think I did one more view of this that has the distribution, and that looks like this. So there's the density plot of the difference between the means, the sampling distribution, and you see 0 here, and the lower and the upper. So that sort of confirms what we got when we ran the magic function. And that's about it. Going back to our framework here, we ran the prototype in Acture, pushed JavaScript into both MouseFlow for the screen capture, and into Excel, and finally into R, and took advantage of the amazing, comprehensive, and skillfully organized user testing framework from Dr. Soro and Dr. Lewis. And I guess it would be good to put this in perspective. The early stage usability testing is right at the heart and core of the overall design cycle, and all these things feed each other. The really early research feeds into some early screen design, and then that can feed this testing cycle where you get really detailed feedback on functional designs, and then that outputs a problem matrix where things can be fixed and further discussed and further researched, and it all goes round and around in a beautiful spiral and comes out with a viable solution. Thanks for listening.